Okay, so today's topic will be covariance, and then we will talk about correlation. Before that, let us quickly recap what we have learned so far. So I have a random variable on a probability space, and the kth order moment is expectation of x to the power k. If x is a discrete random variable, then you will sum. It will be a summation of y to the power k into probability y equal x equal to y. And if x is continuous, then you will integrate. That will be integration of y to the power k fy dy, where f is the density function. Now if the kth order moment is finite, that is expectation of mod x to the power k is finite, then all the lower order moments are finite. Okay, so if ex square is finite, then x is square integrable, and it has set to a finite variance or formula hole A2. Now now comes what I want to talk today. Suppose x and y are two random variables, square integrable baad dijiye, are two random variables with finite variance. Okay. Now variance is finite if and only if ex square is finite, so এই কারণে square integrable কোয়া হয়েছিল. So let me make it simple. So যদি x and y দুটা random variable হয়, both having finite variances, then x into y, then that also has a finite expectation, and then there is this famous inequality. We are not doing the proof over here. That inequality is called Cauchy-Schubert's inequality, and that is expectation of mod x into y square is less than equal to ex square into uy square, or you could write expectation of mod xy is less than equal to square root of ex square into uy square. Now this is not very difficult to prove if x and y are two simple random variables, কারণ আমি এটো আন্ডারগ্রাজুয়েট লেভেল ম্যাথমেটিক্স হতে পড়িছো যে if I have a1 b1 a2 b2 ak bk k pairs of real numbers, then mode of the sum of products, that is mode of a1 b1 plus a2 b2 plus ak bk, that is less than equal to square root of summation of ai square summation of bi square. এটো by induction proof করিব পারি, and using this we can prove this inequality for simple random variables x and y. Now of course in general proof to develop involved হয়. So anyway, it is enough for us to know যদি x and y দুটা random variable এর variance finite হয়, then what you have is expectation of x into y is finite. And of course by what I have just mentioned, since ex square ey square are finite, so expectation of x and expectation of y are also finite. So now what we can define is covariance of xy. Covariance of xy is expectation of x into y minus expectation of x into expectation of y. Now this is also equal to expectation of x minus expectation of x into y minus expectation of y. তার মানে deviations from mean or product law তার expectation law. Now my query is if both the random variables are equal, so if I put y equal to x, then what will I get? So if you compare with the above formula, then this will be, if y is equal to x, this will be ex square, and this will be expectation of x whole square. So covariance will become variance. So if you put y is equal to x, then covariance will become variance. But in general, this is what it is, and because of Cauchy-Schubert's inequality, you see one thing. Okay, let me not bring it right now. So variance is non-negative valued, but covariance is not necessarily non-negative valued. Covariance can be negative. Okay. So now here are some properties of variance and covariance that are important. That if x and y are two random variables, square integrable likha asile note 2, that means finite variable, are two random variables with finite variance. এটা হলে তোমাদের বুঝিবলে ইজি হবে, with finite variance, then expectation of ax plus y is expectation of x plus expectation of y. A2 conditional কারণে you don't need the finite variance condition. For this, it is enough to say that x and y are integrable or expectation of x, expectation of y are finite. তেনেহলে এটু হবে, এটু কাই expectation is linear. কিন্তু square integrable condition যদি থাকে, definitely this will be true and something more will be true. What more, that this turns out to be a square variance of x plus variance of y plus twice a covariance of xy. Now if you want the proof, then expectation of ax plus y minus expectation of ax plus y. So you can see this will be expectation of a times x minus expectation of x plus y minus expectation of y whole square. That's a plus b whole square formula bhangi take the expectation of each part. So that is what it will be. It will be a square times variance of x plus variance of y plus twice a covariance of xy. Now variance of x plus c is variance of c. Can you tell me what will be covariance of a to my erilu? Question. So you have to tell me what is its relation with covariance of x, y. So that is something you will have to tell me. A2 logot relation to ki. If x is non-negative value random variable, then expectation of x is equal to 0. Then probability x equal to 0 is 1. If variance is non-negative, then variance of x equal to 0 implies probability x equal to x is 1. So এটো তোমার কোরপর আহিব. So there is an inequality called Markov inequality that I will maybe talk about in the next class. So most importantly, so covariance of A2, this you will do, and also another question is question number, let me say 1, and then question number 2. Can you tell me what is covariance of cy, where c is a constant? Where c is a constant. So this is what it is. Next time in the class I will talk about correlation coefficient. Whenever we have k variance, one thing also I want to tell that equal to dhara x1 x2 sorry here x1 x2 xk. So I've got k random variables with finite memory with finite variance, then covariance of then this variance of x1 plus x2 xk this is equal to what? So that I will tell you in the next class. This will be summation of variance of xi plus sum over I 2 times sum over I less than j covariance of xi xj. So that's where covariance becomes very important. When you take the variance of the sum, then variance of the sum is the sum of the variance plus sum of all the pairwise covariances. Then another thing, if x and y are independent, then random variables independent random variables, then covariance of xi is 0, covariance of then covariance of xy is equal to 0. However, the converse is not true. Converse not necessarily true. Example, suppose x is equal to plus minus 1, x is equal to plus minus 1, x is 1 with half, and this is also equal to probability x equal to minus 1 and y is equal to x square. Then what is covariance of xy? So I leave it as an exercise for you to try. Okay, so please try this.